I want us to talk about something called prime factorization. Prime factorization is a very important way we can use prime numbers to break down actually composite numbers. Any number that is a composite number can actually be written as what we would say is the product of prime factors. In other words, I can write a multiplication problem made of nothing but prime numbers to give you any composite numbers. And so let's review a little bit about how factors are used. For example, if I had 12, I can write the number 12 as 1 times 12, as 2 times 6, or as 3 times 4. And of course, I can reverse those and do 12 times 1, 6 times 2, and 4 times 3 as well. But those all have composite numbers in them. 4, 6, and 12 are all composite numbers. But there actually is a multiplication problem that uses only prime numbers to give me 12. I want you to pause the video and see if you can figure out a multiplication problem. And it may have to have more than 2 factors that uses only prime factors to give you 12. Okay, I hope you've tried it. If you have tried it, what I think you've realized is this, that 2 times 2 times 3 will give you 12, doesn't it? I mean, there's more than one way you can arrange that. 2 times 2 is 4, and we already know that 4 times 3 is 12. Or you could say 2 times 3 is 6, and 2 times 6 is 12. But 2 times 2 times 3 is 12. That's what you call the prime factorization of 12. One way to write 12 is 2 times 2 times 3, and that only uses prime factors. And that is going to come into play so much in the future. Prime factorization is one of the easiest ways to make complicated numbers simpler. And so let's talk about how a quick way to find the prime factorization of numbers. I'm going to teach you something called a factor tree. And here's how I would make a factor tree for 12. We actually start at the top of the tree with our composite number. And then it's going to have branches. And each branch is going to be a multiplication problem. And so you could pick any multiplication problem that gives you 12. The only one we don't use is we don't use 1 on a factor tree. Since 1 is neither prime nor composite, it's not useful. That's why we didn't list it as a common factor a few videos back. And so perhaps you chose 2 times 6 as your composite, as your factors that gave you 12. And you could have done 3 and 4 as well, but we're going to go with 2 and 6. When you see a prime number, it's the end of a branch. I go ahead and circle my primes. 2 is a prime factor of 12, but 6 is composite. Every time I see a composite number, I know that it can be broken down into prime factors as well. And so what is a multiplication problem that gives me 6? Well, the only one other than 1 times 6, which I can't use, is 2 times 3. And I see that 2 is a prime factor, and so is 3. And that's one way I could find that the prime factorization of 12 is 2 times 2 times 3. So let's try a bigger number, and I want you on your own to try the prime factorization. I want you to try to find the prime factorization of 72. Remember, what happens is you can branch that into a multiplication problem, and every time you get a composite number, you know you can break it down further. So why don't you pause the video and see if you can find, using this factor tree, a multiplication problem only using prime factors that gives you 72. Okay, I hope you've tried that. I'm going to go ahead and try that. I'm going to use 8 times 9. 8 times 9 is 72. I have it memorized. Now when I see that, those are both composite numbers. And when I see a composite number, I know I can always make 2 more branches. 8 is 4 times 2, and I recognize 2 as a prime, and 4 is composite. 4 is 2 times 2, and those are all prime numbers. Now over here at 9, the only way to get 9 is 3 times 3, and that's prime. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. And there's not a particular order they have to be written in, but what you'll notice I do is I start with the lowest factor and I keep it in order, just because that means if we all do that, then all of our prime factorizations are the same. Now, it's possible that some of you did 72 on a factor tree and you didn't start with 8 and 9, but I'm going to show you that it doesn't matter which factors you start with. So perhaps somebody did 72, but they said it was 6 times 12. Well, if you did that, you would actually end up with the same thing, because 6 is 3 times 2, which are primes. 12 is 4 times 3. 3 is a prime. And 4 is 2 times 2. And we still have 2 times 2 times 2 times 3 times 3. The prime factorization remains the same.